Welcome back to the Scotti-BYTE channel, and this is Scott. So I thought I would rewind here a little bit and take a step back and go back to some of the basics that people have been asking about, but that I haven't covered in a while. So today we want to talk about virtual local area networks, or VLANs. And so virtual network interfaces are a great way to boost network efficiency and security. And virtual LANs, or VLANs, are a network range different from your main LAN, and most people by default use the 192.168.1 network, and VLANs typically use a private address space that is different from one of the public address spaces on the internet, although companies have dedicated public address spaces that they use, but private address spaces are normally 10.0.0.0, 172.16.0.0, and 192.168.0.0. And so you have a wide range of addresses to choose from. And so managed routers, access points, and switches can offer and manage VLAN access. And it doesn't really necessarily mean that you need a managed router or managed switch in order to perform the creation of a VLAN, but actually being able to use a VLAN in a useful way typically requires having a managed device. And that means that if you got your router from your ISP or a typical retail router, it is probably not a managed router, and therefore it does not have a way to create and manage VLANs. And also you can't allocate switch ports to particular VLANs, and you can't offer wireless Wi-Fi SSIDs on different VLANs. So these are all capabilities that you get when you have a managed network. So Mac VLAN is the easiest way to create VLANs. And VLANs let you isolate traffic on your network, both for security and performance. And so today we're going to talk about how to create and use VLANs. One key and very important thing to understand is that the creation and management of VLANs requires a managed router. And the reason for this is because you might want to have a VLAN offered in a given address range. For example, something like 192.168.10.0 with the subnet mask of 24. And if you were going to create that VLAN, you would want that VLAN to be able to offer services such as DHCP. And so that's one reason that you might want to have a managed router. So here we are on my Ubiquiti UniFi UDM Pro, and this is just one example. This is what I use as my network here, but your mileage may differ. You might use pfSense, or you might have another router that supports this. So here on my UniFi router, I'm going over to the settings by clicking the gear, and up here it will list all of my Wi-Fi networks, and it's also listing all of my regular networks as well. And so I want to go ahead and create a new network. Since I already have a VLAN 10 that I mentioned earlier, for the purposes of this demonstration, I'm going to create a VLAN 100. And I'm going to do so by clicking on the gear here next to networks. And then I will be able to say I want to create a new virtual network. Once I come up here, I can go ahead and give this virtual network a name. I'll just go ahead and call this test. And then here it asks for the address space. Earlier I said that I was going to make this VLAN 100, and by convention I like to go ahead and specify 100 as the third octet just to make it a little bit self-documenting. And so I want to go down here and click Manual, and then I want to change my VLAN ID to 100. And so my host address is my gateway address, which is 192.168.100.1, which is the address that will be used as the gateway for any new devices on that network range. And here it is created a IP range of 192.168.100.6 through 192.168.100.254, and that is the DHCP scope, or the range in which DHCP addresses will be allocated. And so I also have a check mark here that says allow internet access, which means that anything created on my VLAN will also be able to access the internet. So I'll go ahead and click add, and that will add my new network. Companies will typically use VLANs by allocating a group of users to a particular VLAN range. If I go over here to my unified devices and I select one of my switches, let's say I select this switch in my office, and I go ahead and go over to Port Manager, I could pick a port number, for example, port 5 here. And when I select port 5, it says, what is your native VLAN or network? And by default, it's using my default LAN, which is 172.16.0.0 with a subnet mask of 16. If I go ahead and click the down arrow here, I could select our new VLAN 100, and I could say apply changes. And what that would do is if I had any computer plugged into port 5 on this particular switch, then it would automatically get an address in the range of 192.168.100. Here we are over in Windows 11, and I've opened a PowerShell window, and we'll do an IP config, and you'll see that I currently have an address of 172.16.1.132, and my default gateway, otherwise known as the means to get to other networks such as the public internet, is 172.16.0.1, and that means I'm connected to my main network. So what if I wanted to connect my Windows 11 to a VLAN instead? Well, I'll go ahead and right click on the start button, and I'll go up to computer management. And in computer management, I will go ahead and select device manager, and in device manager I'll open network adapters, and in my particular case my Windows 11 is a virtual machine, and so its network adapter is Red Hat VirtIO Ethernet adapter. I'll go ahead and right click it and go to properties. Once we get to properties, I'll go to advanced, and I'll scroll down and I'll click VLAN ID. You notice the VLAN ID is currently 0, otherwise known as the untagged network, so it is not any particular VLAN, which will default to the main LAN. Another way to connect to your VLAN main network would be to specify VLAN 1. But since we created our VLAN 100 on our managed router, I'll go ahead and tell it I want to have my VLAN ID be 100, and I'll go ahead and click OK. Then I'll come back over here to the PowerShell terminal, and I'll do an IP config /renew, and that will go ahead and ask for an address from the DHCP server. And the DHCP server has changed because we are on a new VLAN. And you'll notice my old address was 172.16.1.132, whereas my new address is 192.168.100.83. Notice my old gateway, the way that I get off the network to other networks, is 172.16.0.1 originally, and now my gateway is 192.168.100.1. Let's go ahead and revert this back, and we do that by right-clicking on the network adapter again, going to Properties, going to Advanced, scrolling to the bottom of the list, clicking on VLAN ID and changing the VLAN ID from 100 to 0. I go ahead and click on OK, and then I come back down and do another ipconfig/renew, and here we are back on the original main LAN of 172.16.1.132, and the default gateway has also reverted to 172.16.0.1. The entire point of VLANs is to be able to have one physical Ethernet adapter point to multiple networks at the same time. So let's go ahead and click on the Start button, and let's type in features. And once we type in features, you'll get a turn Windows features on or off. Go ahead and click that, and another window will open with our Windows features. Before we can create multiple VLANs on the same physical Ethernet adapter, we need to have a virtual switch. So in Windows features, go down and click the check mark next to Hyper-V and go ahead and say OK. Before we can use the Hyper-V virtual switch, we're going to need to go ahead and restart Windows. Once Windows restarts and you log in, go ahead and click down here in the search and type in PowerShell, and then right-click on PowerShell and say Run as Administrator. And then go ahead and acknowledge the prompt, and you'll get an administrative PowerShell. We have to find out the name of our network adapter, so we'll go ahead and do a get-net adapter, and it will come back and tell us what the name of our adapter is. Notice that the name of our Ethernet adapter is Ethernet Instance 0, and so we're going to go ahead and create a new virtual switch with Ethernet Instance 0 with this command. We want to delete the virtual switch that Hyper-V created when we first installed Hyper-V, and we do that with the remove-VM network adapter. At this point, I can create a virtual Ethernet adapter by doing an add VM network adapter, and I'm going to call the name of my network VLAN 100. This is completely an arbitrary name, and I'm using the VLAN virtual switch, and I'm setting it to VLAN 100. And then once that executes, I have a VLAN 30 also on my network. So just for fun, I'm going to go ahead and execute the same command to create an adapter for VLAN 30. And likewise, I call it VLAN 30, and then over here the VLAN ID is 30. And finally, I'll go ahead and create a VLAN adapter for our main network using the untag VLAN 0. And finally, I'll do an ipconfig/renew, and it should go ahead and acquire addresses for each of those VLANs. And it says an error occurred while renewing interface VLAN 100 And part of that is because we're dealing with Windows. But let's be patient here and see what it ends up doing. And so what we have is we have VLAN 30 with an address on my main VLAN. We have main LAN, which does have an address on my main LAN. And then we have the default switch, which has an internal address. So like most other things in Windows, let's go ahead and restart Windows and see if this fixes itself. Now that I've rebooted Windows and started another PowerShell, I'll go ahead and do an IP config in here. And we will have a VLAN 100 adapter with the address of 192.168.100.23 with the gateway of 192.168.100.1. We have a VLAN 30 of address of 192.168.30.138 with the default gateway of 192.168.30.1. And then I have an adapter I created called main LAN, and its address on my main network is 172.16.1.207, and its gateway is 172.16.0.1. And everything here is absolutely correct, which just proves that we had to reboot Windows. And finally, we have the Ethernet adapter for the default switch, and it is using an internal address of 172.27.0.1. Since it really doesn't go anywhere, it's just used to facilitate the virtual switching to create the virtual interfaces. We can also remove interfaces with the commands such as remove-VM network adapter, and we've specified VLAN 100. And that will go ahead and remove our VLAN 100 virtual adapter. And likewise, I can remove the VLAN 30 adapter. Of course, I accidentally typed 3330, so it's VLAN 30 if I type it correctly. And then once that happens, then I can go ahead and do another IP config, and all you'll see here is my main LAN adapter at 172.16.1.207. Here I am on my Ubuntu 2404 desktop, and I'm going to do an if config so we can see the configuration of the network. I have one network device which is named ENP5S0, and its address is 172.16.13.13, which is an address on my main network. The easiest way to create VLANs in Ubuntu is to use NetPlan. So I'm going to do a cd/etc/netplan, and then I'm going to do an ls. You should probably have one NetPlan file. If you don't, feel free to delete the others and keep only one. The number in front of the NetPlan file indicates the order in which multiple NetPlan files can be executed. So if I do a sudo nano on 10-lexc.yaml, which is what my file happens to be called, you see here that it uses Network Manager, and it uses ENP5S0, and DHCP4 is equal to true. We're going to replace that file with this one, and this one is going to use Network D, and it's going to define ENP5S0, and it's going to define VLAN 100, and you'll notice here that I also have VLAN 200 rather than VLAN 30. The reason for that is because I went back and created a VLAN 200 because, unlike Windows, this was a virtual machine, and this virtual machine was conflicting with the network on its host. So therefore, I now have two VLANs that I can use here, VLAN 100 and VLAN 200. I do a control O and enter to write the file out, and a Control X to exit the nano editor. I can do a sudo netplan generate, and that just checks for the validity of the file and goes ahead and makes sure everything is okay. And then we can do a sudo netplan apply, and that will apply our new configuration. To see the configuration of the network, now we simply do an if config, and you'll see that we have at the top ENP5S0 still has the 172.16.13.13 address on the main LAN, but now we have VLAN 100 that has an address of 192.168.100.151, and then we have VLAN 200, which got an address of 192.168.200.150, and both VLAN 100 and VLAN 200 got their addresses from the respective DHCP servers on my router. Now that we've covered how to create VLANs in both Windows and Ubuntu, the real question is, why even have VLANs, and how are VLANs normally used? Well, see, IP traffic is broadcast-based. And since it's broadcast-based, the fewer nodes that you put on a particular network or address range, you have fewer conversations and therefore less traffic and less conflicting traffic. The other reason is sometimes you want to isolate traffic for security reasons. Prior to the time that we had VLANs, you might have had an office building, and in that office building, let's say it had 7 floors. You might have had a router, and that router might have had to have 8 network interface cards in it, and each network interface card might have connected to a separate wiring infrastructure on each of the 7 floors of the building. And then we might have assigned a separate address space for each of those. The advantage of VLANs is that basically you can have one network interface card in a computer, and that network interface card can represent multiple different virtual LANs, and it can communicate to them separately, even though they're running over the same network interface card and even the same network cable. So most commonly nowadays in offices like this, what you would run into is something that might look like this. So what you're looking at here is one of my Unify switches on my network, and if I arbitrarily pick a port, like say port number 18 here, it says what the native VLAN or network is. And so that's my main network. And you can have what are called network profiles or network port profiles. And what they do is they specify which VLANs are allowed on which ports. And by default, at least in the Unify world, you can gain access to any of those VLANs. And so here it just means that Scott and Cat's LAN, which is that 172.16.0.0 network, which is the one that I'm always creating things on here, is really my main network. And if I click this drop down, I have a choice of changing this particular port number to any of my other VLANs or address ranges. And that would mean that if I plugged a computer into that port, it would automatically gain an address on that VLAN. The thing that is a little bit different about this video is that we showed in the case of Windows 11 and also in the case of Ubuntu that you can have one network interface adapter, and we can create multiple VLAN adapters that can point to different VLAN address ranges. And this can be useful for given applications, and it can actually even allow you to perform routing functions from within an application, or you might have an application that just has a need to communicate with multiple different Ethernet interfaces. That being said, you'll always have one default route, but that doesn't mean that you can't communicate on other of the VLANs as well, depending upon what your requirements or needs are. So let's shift gears here for a little bit and go over to one of my Incus servers. And if I do an Incus list here, I don't currently have any containers set up. So if you've watched the channel for a while, you know that I like the Incus virtualization system because it's a very powerful hypervisor for both containers that share the kernel of the host and also Incus virtual machines. So we're going to apply the same type of logic here to an Incus container, and in order to do so, we're going to begin by creating a profile. You'll recall that we can use profiles for various different things. If you watched Incus containers step by step, one of the things I introduce is a profile called the bridge profile. Well, this time we're going to create a profile called simply multi-net. So I do an Incus profile create multi-net, and it goes ahead and creates this multi-net profile. Then I'm going to go ahead and go in and edit it with Incus profile edit multi-net. It pops up into the editor, and at this point this thing really doesn't do anything. It's nothing more than a template. So I'm going to use Control K's to go ahead and clear out the contents of that file. And we're going to replace those contents with the definition for the VLANs that we've been working with, or somewhat like them. So we're going to go ahead and create a Ethernet 0, which is always part of an Incus container, and it's always bridged through bridge 0 on our Incus server. And that's basically what the bridge profile is. But then we're going to create an ETH1 device, and it's going to use Mac VLAN. It will also use as its parent device bridge 0, but this particular virtual NIC will connect to VLAN 100. And likewise, we're going to create an ETH2 device, and that one will be connected to VLAN 200. And we give this thing, of course, the name multi-net, which was what was originally created. I go ahead and do a Control O and Enter to write the file out, and a Control X to exit the nano editor. Now let's go ahead and launch a container using our new profile, and we do so with an Incus launch images :Ubuntu /24.04. We'll name the container test. It will use the default profile, which simply tells it where to get its storage from, and this will be coming also from the default pool. And then we use the profile multi-net that we just created. And I'm also putting the switch on here, boot.autostart equals to true, which means that any time that the Incus server starts, this container starts as well. Let's go ahead and connect into our new test container with the command Incus shell test. And once you're inside of a new container, as always, it's always a good practice to go ahead and update the repositories and take any updates on any of the software components, which in this case is the basic operating system. And normally when you create a container, it probably won't have to take very many updates, and in this particular case, it did not. Let's go ahead and install net-tools just because I like the way it formats the network information, and let's install the nano editor. Let's take a look at the current configuration of the network. with an ifconfig command. And what we're seeing here is we're seeing device ETH0, which got an address on the main LAN of 172.16.1.184. We're seeing device ETH1 that we created, but it does not have an address. And we're seeing device ETH2, and it also does not have an address. And then, of course, we have our loopback connector. Recall that the way that Ubuntu manages its network interfaces is through a program called NetPlan. So if we cd over to /etc/netplan and we do an ls command, you'll see that there is one file called 10-lxc.yaml. So if there are multiple YAML files, they're executed in the order of the number that precedes the file. I always recommend, for simplicity's sake, to have just a single file as opposed to multiple ones. So let's go ahead and jump into the editor with the nano 10-lexc.yaml and see what's out here. And this kind of explains exactly why ETH0 got an address, because we have only one Ethernet defined in the NetPlan file, and it says that DHCP4 is equal to true. And so when the container booted up or started, it went ahead and assigned an address based on that NetPlan configuration. So let's just go ahead and wipe this file out and replace it. And we'll replace it with a very simple NetPlan file that simply says ETH0 should get a DHCP address. ETH1 should, and ETH2 should as well. And if you have DHCP6 configured on your network, the same will be true of the DHCP6 addresses. So we'll go ahead and do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. And now all we need to do is a NetPlan apply, and once the NetPlan apply completes, if we do an ifconfig now, we will see that ETH1 has an address on VLAN 100 of 192.168.100.246, and Ethernet 2 has an address on VLAN 200 of 192.168.200.172. If I go to my Lex console GUI interface and take a look at the test container, you can see here that it does have an address for ETH0, the address for ETH1, and the address for ETH2. If we go into the test container and we click on devices and we click on network, we can then again see that ETH0 is a bridged device, whereas ETH1 and ETH2 are both Mac VLAN devices. So in summary, VLANs provide a very powerful means to isolate your network traffic. And Mac VLAN is the easiest way to create and use network interfaces on a VLAN. And since Mac VLAN is virtual, it allows the creation of many different virtual interfaces on a single physical Ethernet network interface. And since IPv4 is broadcast-based, Mac VLAN improves performance by isolating traffic. And Mac VLAN increases security by isolating user traffic as well. And so examples of good Mac VLAN uses in the home lab would be something like an IoT VLAN or a hosted services VLAN, where you have your services offered through reverse proxy, but the actual target servers are located on a VLAN, something I like to refer to as a DMZ or a demilitarized zone. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.